Today we're going to be working on section 10.2, which is volume of cylinders. We're not doing section 10.1 because it's not in our standards. So the focus in chapter 10 will be on working on volume of cylinders, then we'll work on surface area of cylinders, and then we'll look at how volume and surface area of cylinders are affected by changes in the dimensions. For instance, changes in the radius or changes in the height. Today our focus is volume, and we need to understand that a cylinder is a three-dimensional figure that has two parallel congruent circular bases. So you see in the diagram that I have, the bases are the same size. That's what congruent means. We can't have something where it's got a narrower bottom and then works its way up, something like that. This is not a cylinder, right? The bases need to be exactly the same size. And if you think of examples of these cylinders in real life, think of things like soup cans or pop cans, or maybe the base of a silo. There are also cylinders in cars. You know, if you think about cars that are 4 cylinders, 6 cylinders, 8 cylinders, they are literally this shape. Now, we need to know the volume formula, and the formula that I have circled, or not circled, I guess, sort of squiggled here in green, is a very generic formula. V stands for volume. B, you'll notice, is capitalized, and it actually stands for the entire area of the base. So it's not just a base measurement, like a linear measurement, it's an actual area. And then you multiply by the height. I think that it's, this formula that is workable if you understand what the big B stands for. If you don't remember that B stands for the whole area, then you're sort of stuck. So what I did is I put the formula very specific to a cylinder, and that has the little red fluffy cloud around it. The big B has been replaced with an area formula for a circle, which is pi r squared h. So we've got pi r squared. This is really the big B right here. And then the h is height, like it was before. So let me get rid of that. This you need to have memorized. And before I will let you proceed through the test, I will have you write this along with the surface area formula. And if I have to fix the formulas for you, the best you can get on your test is a B. Because if I let you go throughout the test with the wrong formula, you would get them all wrong. So please, if you write these down for every problem you do, you'll get the formula just memorized and it won't be any extra work. Pi r squared h. The other reminder that we need is that volume will get cubic labels because you're looking at how many cubic units it would take to fill it. Think of volume as being 3D. So we need to have either an exponent of 3, or you'll sometimes see the CU, which stands for cubic, in front of a unit, just like cubic feet, cubic inches. Typically, your standard measurements, like feet, inches, miles, are going to get the cubic in front of it, CU. Metric measures are going to get the little exponent of 3. I don't care if I see you write feet with the little exponent of 3. That is fine. I just want you to know that it's cubic units. So we've got a few examples. I think you'll really catch on to this pretty quickly. It's mostly just substituting in and being careful with your calculating. We've got a can of salmon, and it's kind of like, think about a can of tuna, if any of you make tuna salad at home. We've got a can of salmon. It's shaped like a cylinder. The radius of its base is 2. And so I'm going to put the radius here. It's 2 inches. And the height of the can is 1 3/4 inches. We want to find the volume, and I'm asking you to round to the nearest tenth. We're going to use 3.14 for pi. So, writing down our formula first so that we start memorizing it. We've got volume equals pi r squared h. We'll replace pi with 3.14. Our radius is the 2, and we make sure we square that. And then if you want, you can use 1.75 rather than using the mixed number. Now if we take 3.14, multiply it by 2 squared, and then multiply it by 1.75, and then we're going to round. That should give us 22 cubic inches. Example 2. This time I've got the cylinder for you. You'll notice that the height is 15 meters, the radius is 12 meters. So this is just a matter of substituting. So 3.14 times 12 to the second times 15. Be very careful when you're subbing in. You can't just put either of the numbers in for the radius and square it. It will mess your problem up. So calculating, this one we don't have to do any rounding. Get 6,782.4 cubic meters. And there we are. Third example, one more time. This time we've got a coffee cup. And again, when you've got something geometric, it's nice to draw it. Here's my handle. And we've got, this time, a base diameter. So pay attention to those details. Sometimes people go through this so fast, they don't pay attention to the fact that it's a diameter instead of a radius. So the diameter is 3 inches. It's 3 3/4 inches tall. So when we fill out our formula, pi r squared h, instead of using the 3 inches, we have to find the radius. We know that if the diameter is 3, we'll cut that in half. So that means our radius is 1.5 inches. And then we can use 3.75. So go ahead and calculate. I'll calculate that along with you. And we'll round. And so that'll be 26.5 cubic inches. The main thing is remembering your formula. If you've got your formula, I think that most of you will be very successful with this. One last problem I want you to look at is a problem in which you're given the volume. So this time the volume is 565.2 cubic feet. You're also given the height. The height is 5 feet. And we want to know what the radius is. So if we take our formula and we substitute in what we know, we have 565.2 in place of the volume. We know we've got 3.14. We don't know the radius, so our radius squared stays. And then our height is 5 feet. Our goal is to get r squared alone first before we can then get to r. And we've got two things going on over there. So again, it's kind of nice to clean it up. So if we just take these two numbers and multiply them, we can do that because multiplication is commutative. We have 565.2 equals 15.7 times r squared. Now we can see that, all right, the 15.7 needs to be divided in order to get our r squared alone. And when we do the division, we get 36. Now if you recall, back from when we were working on area of a circle, to go from r squared to r, we need to take the square root of both sides. And I'm hoping that you don't need to use your calculator for this. If you do, you do, I guess. But if you think about it, what number times itself gives you 36? Well, that's going to be 6. And that gives us r. The last thing we need is a unit. And now we've got to kind of stop and think, do we want feet? Do we want square feet? Or do we want cubic feet? Since radius is just a linear measurement, we just want feet. And we're done. Please let me know if you have any questions. Good luck.